Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Alright, welcome to Geometry. Geometry, Lesson 1, Module 1. Okay, starting geometry. So before we do get started, I brought in the definition of the word geometry, and the noun is the branch of mathematics concerned with the properties and relations of points, lines, surfaces or planes, solids, and higher dimensional analogs. A particular system of geometry, non-Euclidean geometry, is a different level of geometry that you could take in college where it deals with three-dimensional geometry. And then we have the shape and relative arrangement of the parts of something. The geometry of spiders' webs, for example. Okay, so let's get started on lesson 1. Construct an equilateral triangle. So we're going to be doing constructions in geometry, and once you start doing constructions, you can learn a lot about shapes and how their angles are affected by different things that we manipulate. Okay, so we're going to be using some tools here. So if I click on here, I have a ruler, a protractor, a geodraic, how do you say that? Geodraic, it's like an angle former, and a compass. So, okay, so I always have trouble with that word because it's German, I believe. And it's, oops, geodraic. Okay, anyway, I don't use that. I use rulers, protractors, and compasses. Okay, so let's move on. Lesson 1, opening exercise. Joe and Marty are in the park playing catch. Tony joins them, and the boys want to stand so that the distance between any two of them is the same. Where do they stand? How do they figure out precisely? What tool or tools could they use? Okay, so if I have 2 points and I draw it like so. So here are the 2 boys playing catch. Their names are Joe and Marty, and then Tony joins them, and they all want to be the same distance apart. How do we do that? Okay, well, let's say that Joe is at point A. Joe's right here. And Marty is at point B, right here. How do I place Tony, who comes along, so that the distance from A to B, or Joey to Marty, would be the same if we went over here? So if we put Tony here, he is the same distance as this, but he's also the same distance from B. So a triangle that has 3 sides that are equal in length is called an equilateral triangle. And so if this distance is 10 feet, then I want a point somewhere down here that's 10 feet from A and 10 feet from B, or it could be up here. So what I'm going to do is I'm going to take my compass, okay, and I put compass the point on A, and then I stretch out the compass to the point on B. Let me just move it a little bit. Okay. And then I'm going to draw a circle. All right, so by definition, a circle is a set of all points that is equidistant from the center. So AB would be my radius of this circle, and if I put Tony anywhere on this red line, he'd be 10 feet from A, because the distance from A to the edge of the circle is 10 feet because all radii are equal. Okay, so now I'm going to do the same thing, except I'm going to flip this around. I'm going to put the point on B now, so that I'm drawing another circle around here on A. So I've drawn 2 circles, and the radius of circle B is also 10. there are two locations on this earth where we could place Tony so that he is 10 feet away from both Joe and Marty, and that'd be here or here. And then once I do that, I can draw a segment. Let's go to here and draw it from here to here, and then from here to here. Okay, let me just fix that a little. Okay, so then if I get rid of this circle and get rid of this circle, I now have an equilateral triangle where all three sides are 10 feet, if the first side was 10 feet. Okay, so now we can talk about what we just did. It says fill in the blanks below as each term is discussed. The blank between point A and B is the set consisting of A, B, and all points on the line AB between A, B. So it's called the segment. Okay, so that's a line segment. It has two endpoints, and it's the straight line in between those 2 points. So the segment between points A and B is the set consisting of A, B, and all points on the line AB between A and B. B says, a segment from the center of a circle to a point on the circle is called a radius. And C says, given a point C in the plane and a number r greater than 0, so a radius that's positive, the blank with center C and radius r is a set of all points in the plane that are distance r from point C, and it is called a circle. Okay, the circle with center C and radius r is a set of all points in the plane that are distance r from point C. Note that because a circle is defined in terms of a distance, r, we often use a distance when naming the radius, example radius AB. However, we may also refer to the specific segment as in radius segment AB. So we're also going to learn how to read geometry. So that says right there, segment AB. Okay, page 2, example 1, sitting cats. You need a compass and a straight edge. So let me get my compass. There's my compass. I need a ruler. That's what they mean by straight edge. And there's my straight edge. Okay. Margie has 3 cats. She has heard that cats in a room position themselves at equal distances from one another and wants to test that theory. Margie notices that Simon, her tabby cat, is in the center of her bed at S. So here is the tabby cat at point S on her bed. While Jojo, her Siamese, is lying on her desk chair at J. So here's her desk chair, here's point J, there's the Siamese cat, Jojo. If the theory is true, where will she find Mac, her calico cat? Use the scale drawing of Margie's room shown below together with only a compass and a straight edge. Place an M where Mac will be if the theory is true. So I'm going to take the ruler, let me switch to arrow, and I'm going to put it on the location of Jojo, which is on the computer chair. Okay, and then I'm going to open this up . Let's see if I can make this larger. Okay, so I had to adjust the drawing, but anyway, I have J, I have my point on J, so I'm going to make a circle with center J and radius of the length of segment JS, which if I drew a segment there, it would be approximately 93 centimeters. So if I spin this around like so, there is the circle. So the other cat, Mac, if he's in the room, he's got to be somewhere on this line right here, because that goes outside the room. So then I'm going to switch this around, and I'm going to move the compass so that S is my center and SJ is the radius of circle S. And I'll change this to blue now. And then if I draw a circle around like this, what I've just done is made two circles with the same radius, which is a distance SJ. So if I drew a segment here from J to S, that would be the radius of both the red circle and the blue circle. Okay, so when doing that, we came to a point where the red circle and the blue circle intersect, and that is going to be where Mac is. So Mac is on the bookcase. The other possible solution is down here, but that's not in her room. Okay, so let me get some of this out of the way. So let me erase the circles. And let me get rid of the compass. Alright, so if I measure this, it looks like about 92, 93 centimeters. And then if I rotate it, and I measure from J to M, it's about 92, 93 centimeters. And then if I brought my ruler over here and put 0 here and rotated it and measured, again, I'm at about 92 or 93 centimeters. So if I drew line segments from J to M and S to M, which I will do, then that will be the location of Mac, and that would have created an equilateral triangle. So all three sides are the same length of 93 centimeters in this drawing. Okay, page 3 brings us to mathematical modeling exercise, Euclid, proposition 1. Let's see how Euclid approached this problem. Look at his first proposition and compare his steps with yours. So proposition 1 says to construct an equilateral triangle on a given finite straight line. Okay, so let's stop there. Finite, the opposite of infinite. Infinite means it goes on forever and ever and ever. So a finite straight line would actually be a line segment because it has a beginning and an end. That's what finite means. So here's the diagram with A, B, C, D, E labeled. And it says, let AB be the finite given straight line. So let me just follow along with colors. So he's saying AB is a finite straight line. So it is required to construct an equilateral triangle on the straight line AB. Let the circle BCD, so circle center B, C, D, not centered, I'm sorry, it's not centered at BCD, it's actually circle A, but it's naming 3 points on the circle, which is called an arc, but it's naming the circle by going around. If you put your pen down and you went B to C to D, and then back around to B, there's your circle. So it says, let the circle BCD with center A and radius of AB have been drawn. Postulate 3. And again, let the circle ACE, so ACE, this circle here with center B, and radius BA have been drawn, postulate 3. And let the straight line CA, where circles cut one another to the point AB, respectively. Okay, and let straight lines CA and CB have been joined from point C, where the circles cut one another, right here, to the point A and B respectively, postulate 1. And since point A is the center of the circle CDB, AC is equal to AB, definition of radius 1.15. Again, since the point of B is the center of circle CAE, B is the center of this circle, then we can say BC is equal to BA, definition of radius, but CA was also shown to be equal to AB. Thus, CA and CB are each equal to AB, but things equal to the same thing are also equal to one another, CN1. Okay, so that is the property, it's called the transitive property. If one thing equals another and a third thing equals the same thing, so in other words, if A equals B and B equals C, then A equals C. That is the transitive property. So that's what this is saying here. Thus, the three straight lines, CA, AB, and BC, are all equal to one another. Thus, the triangle ABC is equilateral and has been constructed on the given finite straight line AB, which is the very thing it was required to do. Okay. So in this margin, compare your steps with Euclid. So what you would do here is write down what we did on the prior page. Okay, page 4 brings us to geometry assumptions. In geometry, as in most fields, there are specific facts and definitions that we assume to be true. In any logical system, it helps to identify these assumptions as early as possible, since the correctness of any proof hinges upon the truth of our assumptions. For example, in proposition 1, when Euclid said, let AB be the given finite straight line, he assumed that given any two distinct points, there is exactly one line that contains them. Of course, that assumes we have 2 points. It is best if we assume there are points in the plane as well. Every plane contains at least 3 non-collinear points. All right, Euclid continued on to show that the measures of each of the 3 sides of his triangle are equal. It makes sense to discuss the measure of a segment in terms of distance. To every pair of points A and B, there corresponds a real number distance A comma B greater than or equal to 0, called the distance from A to B. Since the distance from A to B is equal to the distance from B to A, we're just going from one end to the other or vice versa, we can interchange A and B. Distance A comma B equals distance B comma A. Also, A and B coincide if and only if distance A comma B equals 0. So A and B coincide, meaning they're at the exact same location, only when the line segment has no length. So A and B would be just a point on top of another point. Using distance, we can also assume that every line has a coordinate system, which just means that we can think of any line in the plane as a number line. Here's how. Given a line L, pick a point A on L to be 0, and find the 2 points B and C such that distance AB and distance AC equal 1. Label one of these points to be 1, say point B, which means the other point C corresponds to -1. Every other point on the line then corresponds to a real number determined by the positive or negative distance between 0 and the point. In particular, if after placing a coordinate system on a line, if a point R corresponds to the number R and a point capital S corresponds to the number lowercase s, then the distance from capital R to capital S is distance capital R comma capital S equals the absolute value of lowercase r minus lowercase s. History of geometry. Examine the site at geomhistory.com home HTML to see how geometry developed over time. Okay, relevant vocabulary. Geometric construction. A geometric construction is a set of instructions for drawing points, lines, circles, and figures in the plane. The 2 most basic types of instructions are the following. 1. Given any 2 points A, B, and a straight edge, can be used to draw the line AB or segment AB. And 2, given any 2 points C and B, use a compass to draw the circle that has its center at C that passes through B. Abbreviation: draw circle C, center C, radius CB. Constructions also include steps in which the points where lines or circles intersect are selected and labeled. Abbreviation: mark the point of intersection of the line AB and the line PQ by X, etc. Okay, so I'm going to do this rather than just say it. Okay, so here we go. It says, given number 1, we're doing number 1. Let me get my pen. We'll do it in red. Number 1. Given any 2 points A and B. So I'll put a point here, call it A. I'll put a point here, call it B. A straight edge can be used to draw a line AB or segment AB. So what they're saying is I can take this ruler, usually puts it way up at the top. Yep, so there's 2 of them. Alrighty then. And I can bring this ruler down. Alright, put that right there, rotate it. Okay, so let me just move it just a little bit, right there. So what they're saying is, given any 2 points A and B, which we have here, a straight edge can be used to draw the line AB. So now I can just go like this, move the ruler, and put arrows, like so. There's line AB. Or, if I just start at the point and go to the next point without going beyond, no arrows, then that would be segment AB. So that's number 1. Number 2 says, given any 2 points C and B, alright, so let me erase this, and let me call it C. Use a compass to draw a circle that has its center at C and passes through B. Alright, so let me make this smaller so it doesn't go off the page. So let's just start over, it's just easier. Alright, so now if we have a point B right here, and a point C right here, and it says to get a compass, and go to the top of the page and get it. Okay, it says, use a compass to draw the circle that has its center at C. So I want the point at C, like so, and flip this over, open this so that we come to B, like that. Center at C, that's where you put your sharp point on your compass and the pencil on B. Draw a circle. And there it is. So there is a circle with center C with a radius of CB. So draw circle C, center C, radius CB. So if I wanted to draw the radius now, I would just put my ruler here, rotate it to the center, and draw this segment to C right here. There is radius CB. Okay, so there we have it. Constructions also include steps in which points where the lines or circles intersect are selected and labeled. Abbreviation: mark the point of intersection of line AB and line PQ by X, etc. Okay, so what they're saying here is, let's get this all out of the way. So if we have line AB, so there's a line, here's A, here's B. Mark the point of intersection of the line AB and the line PQ. So if they intersect, all I would have to do is have my ruler go through them, change colors, draw a segment or a line, put arrows on it, and that is line PQ. So I need a point here called P and a point here called Q. And it says, mark the point of intersection of the line AB and PQ by X. So I put a dot here and name it X. So there is a diagram, a construction of 2 lines, AB and PQ, that intersect at X. Okay. Figure. A two-dimensional figure is a set of points in a plane. Usually the term figure refers to certain common shapes such as triangle, square, rectangle, etc. However, the definition is broad enough to include any set of points, so a triangle with a line segment sticking out of it is also a figure. Equilateral triangle is a triangle with all sides of equal length. And then the word collinear is three or more points are collinear if there is a line containing all the points, otherwise the points are non-collinear. So if I focus on point P, point X, and point Q, those 3 points are on the red line, which is called PQ. So point P, point Q, and point X are collinear because they're on the same line. Point P, point X, and point B are non-collinear because they are not on the same straight line. Okay, page 5. Length of a segment. The length of segment AB, that's how you read that, is the distance from A to B and is denoted AB without the line over it. Thus, just the letters AB equals distance of from point A to point B is what that says. So in this course, you have to write about distances between points and lengths of segments in many, if not most, problem sets. Instead of writing dist parentheses A comma B all the time, which is a rather long and awkward notation, we instead use the much simpler notation, just the letters A, B without the segment over top, for both distance and length of segments. Even though the notation always makes a meaning of each statement clear, it is worthwhile to consider the context of the statement to ensure correct usage. Here are some examples. So this here is AB with a segment over top, or a line. I think those are arrows on top. So I'd say line AB intersects. Line AB refers to a line, yes. So this is hard to see, so let me write it. So if I just write this, I'm saying the length of AB. If I put this over top, that is now segment AB. And if I put one arrow on it, that would be ray AB, where A is the starting point. And then if I put another arrow on the other end, now this would say line AB. This is all review from Math 8, but that was 2 years ago. That's why we're reviewing. All right, so now we have, so this says the length of AB plus the length of BC equals the length of AC. Only numbers can be added, and AB is a length or distance. Find AB, segment AB, so that says find segment AB so that segment AB is parallel to segment CD. Only figures can be parallel, and segment AB is a segment. AB equals 6. So that says the length of AB equals 6. AB refers to the length of segment AB, or the distance from A to B. So if I just write the letter, that just means the letters, that just means the length of something. The distance from here to here. The distance from A to B. Here are the standard notations for segments, lines, rays, distances, and lengths. A ray with vertex A that contains the point B. So the arrow is going this way. So A is my starting point or vertex, and B contains the point. So if I drew that, I would draw this ray. This is point A, and B is anywhere on that point, and the ray goes through it. A line that contains points A and B, line AB, I would just take that ray and continue it through A and go the other way with an arrow on the other end. So that says line AB. A segment with endpoints A and B. So you'd write this line segment on top, no arrows on either end, AB, or just simply say segment AB. The length of segment AB is just written with the two letters, nothing above it. Length. The distance from A to B would be written dist parentheses A comma B, or simply AB with nothing over top. All right, coordinate system on a line. Given a line L, a coordinate system on L is a correspondence between the points on the line and the real numbers such that 1, to every point on L, there corresponds exactly one real number, and 2, to every real number, there corresponds exactly 1 point of L. 3. The distance between two distinct points on L is equal to the absolute value of the difference of the corresponding numbers. So let me explain that. Let me draw a line segment. Actually, let me go here and let's draw a line, and let's make it red. Okay, gotta make that a little bit bigger. So I want arrows. Let's go a little darker and try it again. That's better. Okay, so here is a line, given a line, and I'll call it L. Whoops, gotta switch back to my pen. I will call that line L. Okay, to every point on L there corresponds exactly one real number. So if I put a point here and called that 5, to every real number there corresponds exactly 1 point. So there's not going to be another 5 with a different point. 5 is assigned to this point's assigned to 5. If I come down here and put another point and call that 8, this 8 goes to that point goes to that 8, and no other points, no other 8s will be on this line. And then 3, the distance between two distinct points on L is equal to the absolute value of the difference of the corresponding numbers. So I could draw it this way: the absolute value of 8 minus 5 equals the absolute value of 3, which equals 3. But it doesn't matter what order I do it. I could say the absolute value, if I wanted to go this way and say 5 minus 8 equals the absolute value of 5 minus 8 is negative 3, and the absolute value of negative 3 is also 3. So the distance from 5 to 8 is 3, regardless of whether we went this way or if we went this way. Okay, page 6 brings us to the end of lesson 1. Go to your problem set.